Hello, 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 and welcome to another one line of code. I am One Lion, and you are all amazing. Hello, TBD Gamer. You indeed are first. Welcome in. Hope your morning went okay and decently and well. I didn't actually check your announcements. You were tired. Totally understandable. I hope you're able to sleep again soon. Corbetman! Welcome in, Corbetman. Already getting a beautiful fail sound. Thank you so much for that. All right, today is Friday, and Friday on our channel means that it is Community Day. Well, I hope we can make it better, or help it be better, not make it be better. Today's Community Day, which is a day when we invite members of our community to discuss, to bring up topics about software development, about technology, about things you're interested in, things that you Oh, I see. I see, said the blind man to the mute person, deaf person who was listening to the mute singer. We're going to be discussing whatever topics happen to come up. We have reserved some time for Fulisnabo, who wants to do a small presentation on shaders, which is going to be awesome, I hope, provided he does show up. And we'll get that started as soon as he is here and have some discussions about that. But for now, yeah, Community Day, everyone. So if there are any topics, until such a time as Snobble shows up, please feel free to bring him up and we'll have some discussions about it. Currently, I am adjusting some UI that was created by AI. I did some coding, but because I wanted the dashboard page of RTrek to be updated, because every time that I kept relaunching the app and seeing it, I was like, I am tired of seeing this thing. I want it to be a little bit better. So it did a really good job. There was a whole bunch of weird stuff that it did that I'm cleaning up and fixing up. But I gotta show you, this is typical of what you would see with UI that AI generates, which is going to be pretty flat. Well, I guess not really flat, but you know what I mean. It's boring, it's typical, it's across the board, but it gets the job done. And that's all that I'm looking for right now. So if you recall, the dashboard used to just be, or not dashboard, the landing page used to just be something that said welcome username in parentheses, the role name, and then right below it was my to-do list of here's some quick actions that you'll be able to do. Submit a TRN, load data, something else regarding TRNs, I'm sure. And like literally it was that text. And my instructions were simply to flesh out the landing page as a dashboard so that based on the role that the user is logged into. And it did it, but it used a switch statement here. However, I turned it into an authorized attribute, or an authorized view component, which was kind of dumb of me because essentially what I'm saying is if the user has the role intermediate or is in the role intermediate, display the intermediate stuff they can do. If they also have the role final, then display more stuff they can do. And that was dumb because I want it to be based on the active role. So only display the intermediate quick actions if they have intermediate role, and only display the final actions if they have final role. And it originally set it up like that. And I was like, why are you doing it like this? We can use the authorized attribute. Well, friend, user state.active role. Wait, is it not called user state? It is called user state. Active is intermediate. Oh wait, no. User state active role is what I'm trying to do here. Anyway, so yes, bring stuff up. Corbett is saying, I'm learning about WebSockets, have to implement them to redirect audio from RTP. That's cool. Do you have any information you want to share about that? I'm sure it's something that would be very interesting to hear about. I definitely want to hear about it. I know what WebSockets are. I haven't ever used them directly, used them on purpose. I'm pretty sure that's something that gets used by some of the technologies that I use, but I haven't done anything to purposefully use WebSockets, and I kind of want to. Oops, no. Intermediate. This is all I'm trying to do. Cooperate with me, please. Okay, so if the active role is intermediate, we don't need to worry about this because they aren't ever able to select a role that they aren't a part of. Yeah, like Signal R, exactly, DC Aggie. Welcome in. And Marcus Voice Coder is here. Hello, Marcus Voice Coder. I hope you're having a great day. Again, today is Community Day, so don't mind me while I continue working on R-Track. Again, a lot of this stuff, or not a lot, the UI stuff that I'm currently working on is just revamping the AI generated stuff. It generated, or I don't want to keep using the word generated because it's obvious that it's generated. It decided to break up these things that are repeated over and over into a component, but it never ended up using that component, which doesn't make sense. Like, just use the component you made for this. It'll clean it up quite a bit. But yeah, I'll show the UI again shortly, or tallly or something. All right. And TVD Gamer says Community Day, but your title says client work. No, it doesn't. I'm sure that I updated everything, didn't I? Starting. This is Community Day and Side Project. This says Distractable. OBS says that I set the title correctly. The stream title says .NET Live Coding Community Day. Which one says? I did not. I did it before the stream started. I'm sure of it. I watched my dashboard title change. I did it before I pushed the start button even. I saw it. I saw it. You were probably just logged into my stream the whole time because you were so excited about Community Day that you were just like, I'm going to be on here starting last night. Because I'm going to be the first one to show up. And guess what? You were the first one to show up. I see you. You got me. But yeah, so until Snobble shows up, again, please feel free to bring up any topics. I can, of course, bring up topics if you don't have any that you want to discuss. And they won't always be around AI, but I mean, that is what we've been talking about a lot lately, because I am still extremely interested in coming up with some guidelines, even if it's just for our small little community here, for what is the proper use of, what is a good set of boundaries to have in place or guardrails to have in place when using AI in the software development in a professional environment. Marcus Voice Coder says, a client wanted to know when two users were potentially editing the same record, so I use Signal R for that. Awesome. But no, I 100% believe you, TBD, that the title, when you came to the stream, did say .NET Live Coding Client Work or whatever my normal everyday stream title is. Or You know what? You might have seen my thumbnail on the YouTubes. You know what? It's entirely possible I didn't update the thumbnail. Wait, but you wouldn't have seen that on Twitch. Nope, the thumbnail is updated. Weird. Very weird. But again, I really do believe you. Scott is here. Hello, Scott. AI is fun. AI is fun. Sounds like caching issues to me. Bless you. TBD Gamer said, we're enabling Sonar Cloud at work. It has checks in to look for AI generated code. Interesting. Yeah, more interesting things. So what is the goal of identifying AI generated code? Ambitious Mushroom. Oh yeah, the Marcus Voice Coder app. Has it been updated? The Words with Friends. I don't know what to call this. Hello, Plump Tardigrade. You've added an AI word tutor to my word apps. Waits for the key patiently. And Corbettman says, do you know much about cybersecurity? Not really. It's not something that I am very interested about. In fact, I kind of get like low energy whenever I think about making sure that I am protecting our data, all of that good stuff. Do you have your own OpenAI key? Oh yeah, I do. Is this masked? It's masked. Cool. I'll grab that and I'll try it. Give me a second. But let me respond to this. I want to transition into that field within the next 5 years, thinking about red teaming, software development security engineer, or something, and pen testing. Someone on Discord was recently talking about wanting to get together and discuss security, like a highlight on security. And that was in general chat, I want to say. Was it Zerg? No. It was Yaj. It was Yaj Music. Pretty sure. No, it was not Yaj Music. Dukasoft posted a message in resources, and Zulius and somebody Zerg posted. Yes, Zerg. Maybe. I don't know where it was, but Zerg posted and was like, we should make a day of it. We should get together and talk about some security protocols and stuff, because TBD had a response to it as well regarding the claim that software developers, just by virtue of being software developers, typically have a pulse on security, like the ones that have the experience of doing, and like you know the simple things, make these text inputs. You don't trust any input that is provided by the user on the server. And now we have prompt injection to deal with, if that's going to be a thing, in resources and stuff. So it was in the same place that Dukasoft posted the video. Cool. Yes. So it's definitely there. And it was in response, and it was Zerg. So, yeah. Anyway, it seems like Zerg is interested in it, so if you want to talk with them about it, Zerg also streams. Shout out to Zerg. What is your name? I don't know Zerg's username off the top of my head. Good thing I'm following him. It's like Zerg SHW something. No! Dang it, man. My clicking skills are the best. Hold on. I'm trying to do the show more button or link button link because Zerg for some reason is all the way down in this list. Sulfur Lord. And it's not alphabetical or anything. Like Mooniz is way down here, and I'm often watching Mooniz's channel. What's the deal with that? Okay, Zerg SHW. I was right. And Corbett Moon was like Zerg SHW. Anyway, shout out to Zerg. Zerg is working on an AI all-encompassing agent buddy friend named Lisa that has all of the capabilities from a multimodal LLM that is able to see images, do object detection, do OCR on text, do responding in real time, all of that stuff, and has an avatar and everything. So definitely feel free to check out Zerg's stream, but Zerg, I'm sure, would be very interested in continuing a discussion on security. I wouldn't be able to contribute much to it, but you are absolutely welcome to bring that up now. If there are specific topics within security, like you were talking about red teaming, if you want to share information about what you know about red teaming, or if anyone else wants to have more back and forth with you right now, I'll read it out, but I'm not really going to be able to contribute very much to the topic. Oh, I guess to finish my thought, though, Zerg was pretty much indicating that there is just this natural pull towards... Oh, that's what I'm trying to do. I'm trying to go to system. Environment variables. There's this natural pull towards just having at least a baseline level of knowing, or of keeping in mind best practices for security. And TBD Gamer's like, well, yes, and I've seen a lot of instances where we don't really notice the very small things that we should be considering. Oh, I thought I had my OpenAI API in my system variables for various LLM reasons. What's the deal there? Huh. Oh, Marcus, I don't know if I'll be able to find my OpenAI API key without going there and creating a new one. Let me check a different computer real quick. I'm sure it's on Lev. It has to be on Lev. I use a lot of local LLM stuff. So local LLMs, local image gen stuff, pretty much everything hosted locally so that I'm not trying to, I don't know, put my information out there everywhere. Hello? Is it listed as something else? I know that I configured my OpenAI API key somewhere. I have my Hugging Face token. So Marcus, I don't have my OpenAI API key somewhere available. I really don't want to set that up on stream either, because I've made a lot of mistakes recently. If you feel safe and comfortable doing that, I'll definitely make sure not to accidentally show it on screen. Scream, because I know how to speak. I have words. All right. Where were we? Where were we? Where were we? We're both right. Dukesoft did a Soduka, a fancy Soduka for Zerg. Thank you so much for that. Okay, Corbettman says, I just came up with a topic. Might have been discussed a lot, though. That's completely okay if it's what you want to bring up. Again, we will, as soon as Snobble comes in, we will give him the floor. I mean, I'll try not to just be like abruptly ending whatever conversation we have. Slash R slash P slash. I know that I've done it before. Click on my name and click on whisper, I think. Here, I'll start it. I'll start the whisper to you first. Maybe I will. Goodness me. I don't know how to technology. What do you think I am? A technologist? Okay, before you whisper it to me though, make sure to send me a test message that is not the key so that we make sure that it doesn't show up anywhere. It is /W, but why didn't that show up? What is your name? Marcus Voice Coder. You. Here is a message from me. Okay, so you should have gotten a whisper from me, and Snobble is here. All right, Snobble. So we're going to discuss Corbett Min's topic, but first, we went in through the door, but first because we were carrying a tray of blank. Fill in the blank. Oh, did I greet you, Tardigrade? I hope I greeted you. Happy Friday to you as well. We've made it to Friday. Looking forward to seeing what it throws up. I don't know, but Sonar feels it's worth highlighting, so I'll let you know. Cool. Yeah, it's not necessarily the technology that I was super interested in. It's the reason behind searching for AI-generated code. Is it to improve the use of it? Because that's what I care about. Okay, so Corbett Min is going to go pee real quick, but I'll apply to join voice chat so we can discuss the thing after Snobble, though. Yeah, so Snobble, feel free to hop in. We are ready for you. And I did greet you. Awesome. Good. Okay. It says, please use the whisper window for whispers. So when I sent you a message, there should have been, if you are on Twitch, there should have been a little small bar at the bottom that, can I minimize this? Okay. That looks like this. I don't know if you can see this. And it would have my name on it. So you click on that and it'll expand, and that's our whisper window. Yay, up bar. Trying to find all the uses you can of BitGamey's new emojis. All right, you got it. It is tested, and do we see anything weird on stream? No. All right, you should be safe to do it. Are you ready for me to pull you into the you're in Twitch glitch? All right, so in 3, 2, wonderful times. Hello. Yes. All right, we have audio for you on stream and in my ears.
Good. I hope the audio is okay. I don't have any fancy mic.
No, you're good. You're perfect.
And hope the people can hear me in the chat as well, I suppose. Hi to the chat, etc.
Will you be sharing your screen?
I'm planning to share my screen, and
cool.
hopefully it works out for us. So
where's the
I guess
pop out? How do we do pop
out? Can I see? Does this thing work?
Oh, watch stream. Okay. Yeah, and same color scheme, Marcus. So we're going to get to this after Snobble shows us. And we're going to talk about Corbett Min's thing too. After you are done. So I need to figure out how to pop out the video now. It used to be so easy.
Yeah. I wonder when did software peak? I have the memory of everything being easier,
Yeah.
but maybe it's the wrong memory.
How do I stop
Maybe did I
watching?
share it in the wrong way? I just shared
No,
this.
no, 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 no. This is exactly how I used to be able to pop this out. What?
Yeah, I guess I'm starting to become a boomer. I notice now when they change the icon on the apps on the phone, I get annoyed because then I don't find them.
That's okay. I've always been me. I've always been like this. Wow. Okay. Is there a way to collapse this? Is there a way to anything? How do I life? Oh my goodness. Hold on. I'm gonna Google this. Does anyone know how to pop out a stream in Discord? Tap the pop out button. You think that's what it used to be? Yeah, that's what I was looking for. I don't have that button.
Yeah.
Anyone? Anyone?
So
This is 4 years ago, dude. This is what I'm going to spend the whole time doing. You know what? Let's just see if we can turn stream mode on.
I'm looking for options on my side, but currently no success. I can stop streaming, but I guess that's not the right button.
Oh no. I can't turn streamer mode on. Oh, that's a dangerous time to message me, Tardigrade. I'm already confused. No need to confuse me more. All right, let's click on this.
Change stream.
Back in the room. Haha! That is one of the dumbest places for it. So it's on the actual stream room. Like the only place that I found it was on the stream room name. So like, you know how at the bottom it says video connected, and then just below that it has the channel that you're in, the voice channel that you're in. Anyway, right click on that.
Speaking of things I thought was a little bit stupid, but that's just me perhaps. But I try to use this. You might know that Azure Data Studio.
Oh yeah,
Azure Database Studio, something to handle SQL Server in Azure using. It wasn't a plugin, but they forked Visual Studio Code, I guess. So what I thought was a little bit weird was that if you clicked on the name, there was a hidden button that popped up when you clicked on it. Or maybe you hovered over it, but you didn't see it unless you moved the mouse cursor. And that button opened, do you want to drop this DB dialog? For me, it's like, why would you put that? Of course, they ask for confirmation. But for me, just getting the question, do you want to drop a production DB? It's for me, I get scared, right? I don't
yeah, it makes you double take. It's like,
yeah. So,
yes.
the thing was just that, why do they need to put this drop database buttons on the name where you can't see it?
Yeah, that's
so you don't
weird.
know if you're clicking it before you click it. I was like, for my own blood pressure, I couldn't use that tool. And now it's okay.
One of the things that happens to me a lot is I'm used to clicking on drop down menus and pop up menus and stuff, and the ones that automatically pop up where there is an action on the thing that you're hovering over, that's really, really annoying. I do that all the time.
Yeah, I agree. Anyway, so I was thinking, I've done some presentations on. I like shaders. You know that. Most people that have talked to me more than 5 seconds know that. So I've done some 2D shader presentations. I thought it would be fun to do a 3D shader presentation because I learned a few new tricks lately. So I think I can do that I don't know, maybe 30 minutes or something like that. So to introduce people to that, and maybe people get a new hobby, but I can sort of guarantee it's not a useful skill really. It's not something that can help you at work, but it's a hobby. So I thought one lion, how you say it, one lion, yeah, whatever.
Where you want to say it? If you need me to tell you how to say it, I can tell you how to say it, but
okay, go on.
Take your pick.
I go with one lion. I think that's how I mentally think it, but it's
for
game.
Me. Works for me.
And as long as people not call me that bastard or something like that, I'm happy with that. No.
I've been called many things, and I answer to them.
But one lion is not the worst.
Correct. It's actually how I pronounce it.
So I was thinking, show some things here in this tool I have in front of us, and maybe you can be the representative for the chat and ask questions and clarifications if you go too quickly, right? And maybe even if you're lucky, we can incorporate a little bit of your ideas, or maybe it's too complicated ideas and I can't do it. So
I would do my best to keep it simple.
Yeah. So just to give you a little bit of context, right? So this tool you see ahead of you is a tool called CodeLife, which I like, and that's kind of a shader IDE. There are other shader IDEs like Bonsomatics, and you can probably use Visual Studio Code, but I like this one. It's free if people want to use it, but there's a nag screen. So I paid a nag screen. I mean, it will ask you, are you sure you don't want to buy it for 10 seconds? And then you get everything, but you have to watch that screen for 10 seconds. But I like it, so I bought it. And then there are also tools on the web like ShaderToy or Poshbrolly, so you don't need to install stuff to do these things. And the language we're going to use today is a language called GLZ, which is hard for me to say, but it's called GLSL.
Oh, GLSL.
OpenGL shader language, because this is OpenGL. In DirectX it's called HSL, which is also hard to say. High level.
Yeah. HLSL.
It's basically C, though. It's a C language. If you know C, you're good. If you know C#, you kind of have to remove, classes and IO and threads and things like that. You don't have that. But it's like a simplified C#. So if you know C#, you're in a good position to sort of, at least be able to read the code. And what I'm going to focus today, we're going to code really soon, is the fragment shader. So you might see it says fragment here. Here it says vertex. We're not going to do vertex shaders. There are many other shaders. I don't care about them today. So fragment shader is the focus today. And sometimes when I listen to people and talk about shader, they say it's black magic. It's really, really hard. But I think a fragment shader is conceptually simple to do. You can make very complicated shaders, but conceptually not so hard. So what you see here is a function called main_image for some reason. I copied the pattern from ShaderToy, so to make this as compatible with ShaderToy as possible. So this function takes one argument, C, and produces another value, O. And what C is, it's the coordinate of the pixel. So this function is going to run conceptually for each pixel on the screen. And our purpose in life is to produce the output color.
And when you say pixel on the screen, do you mean visible pixel or just anywhere in the scene that is going to be there, since it's, I'm assuming, a 3D scene?
This program is applied to this background image here, right?
Okay.
That is black currently because we're not doing anything. And for each pixel on that screen, it's kind of on a texture as well. So you can also do fragment shaders for textures. And then you will apply it for each texture, but in this case, it's going to be for the screen. So it basically is the resolution of the screen. So that's the thing. Input, and it's called vec2, and vec2 means it's a two-dimensional vector, which just means there are two floating point values here, x and y. So it's kind of like the struct with two floating points. And vec4 means a four-dimensional vector, which is x, y, z, and w, where x, y, and z is the RGB value of the output color, and W is the alpha channel, which is not in use for this thing, but that is the way it is. So So I'm just going to do some coding, and so I'm just going to increment the output color by 1. And now it goes into, light mode, kind of.
Yay, like
So we're going to decrease that very quickly to something else like so. So if I put in 1, the color goes black. If I put in a sort of a decimal value here, it goes gray. So I can sort of change it to 05, 06, and you see it goes more and more white. I can put in negative numbers, it doesn't matter. And I could put in really big numbers, and it doesn't, it's not like the surface of the sun, it's still just 1, still the same white. So it goes between 0 and 1 in this case. Makes sense, I hope. Now, we're gonna make this a program that uses the input coordinate here. So I'm gonna put in c.x here, which is the x coordinate. It's just one, everything is white, but there is actually a pixel over here that is a line here, which is black. And the reason is because the resolution of the screen is 1920 here. So all the pixels, the first cx is 0, then it's 1, then it's 2, then it's 3, and so on. And that's why it's all white. But if I divide by the resolution of the x, over here it says 1920, then I get a nice little gradient. And you might have noticed as well that as soon as I change something in this program, it immediately recompiles and deploys the shader, which I think is really cool. It's very, very... We sometimes talk about hot reload in C#, I think. I would say it's the hottest reload in code.
Yeah, this was even before then. This is like back when Sublime and all of the other text code editors would just update your HTML and CSS immediately. And that used to work really well. And then now it's like, let's have the C# DLLs update. And we'll call that hot reload and have it not be dependable.
Or so, like a female streamer, I don't know if she wants to stand by it, but she said lukewarm reload, and that's what I've been calling it ever since. We can also make a gradient in the y direction by using the y coordinate here. So that's a start. So this is actually a very simple fragment shader, probably one of the simpler you can make. Now, in order to do colors here, I can then initialize this O with 4 values, because I mentioned it's a 4-dimensional vector. In C# we would type new, but we don't have to here. So if I put 1 in the first, it becomes red. And the second, green. And obviously if I type a small value, it becomes less green, right? And I guess most of the audience can guess what the third one will be. It will be blue. And the alpha doesn't matter. Nothing happens. And then we can make a program that is slightly more interesting. So if I take this thing here by before, I take cx divided by c resolution, I get the red gradient. But as a green component, I put, oops, what happened there?
You put math.cosine.
Yeah, I probably had it in my buffer. If I put in the y component, the green component, I put in the y gradient, and then we get the 2-dimensional gradient that goes from black here to yellow, because both red and well, x and y is 1 there, and here only y is 1, and here only x is 1. And maybe we can make it slightly better looking by adding a little bit of blue to it.
G'day.
Now, I'm soon going to get into the 3D stuff, but I just want to mention a very common thing, and you can actually write this a little bit shorter, and people do it all the time, by removing the x component here, and I write like this. And this is actually the same as before, but when we type like this, this vector is kind of expanded, if you get what I mean. The first 2 arguments is filled in with x and y.
Like spreader operator in JavaScript. Yeah,
exactly right. It's like the spread operator. And here we actually are also dividing by dot x and y. So this is actually a 4-dimensional thing, but I'm extracting x and y from this thing and dividing it by that. So that's a very common thing, and it's called swizzling, I believe, in Shaderland. But so far so good, I guess. I hope.
It's fun. It's pretty easy to understand so far. Yes.
Yeah. So now we're going to make a little bit more, perhaps more leap of faith, out of the cliff of math, or whatever you want to call it. Because when we're going to do 3D in Shadyland, in this thing, what we typically do, we do ray tracing. It's not always the case, but in this kind of things I would do is typically ray tracers. And a ray tracer is that for each pixel, we take a ray starting from the camera or the eye, and then we trace a line through the pixel into the world going beyond. And then we're going to, an iterative process, move along this ray until we hit something. And then we're going to do some colors when we hit it. So we need to compute a ray, and ray is a direction in 3 dimensions. So it's going to start by being a vec3. And then it's going to need to depend on this C component, because it needs to be different ray for different pixels. And I'm going to subtract, maybe randomly, e-resolution.y xy. But the reason for that is I want this component to be 0 at the middle of the screen. So in the middle of the screen, it's going to reach half the resolution. So this kind of component will be 0. And then the ray is going to point straight into the screen. And then when we move to edges, it's going to be more negative then. Then the ray will point more to the left. And I go here, the ray going to point more to the right. This is not rigid mathematics, but it's kind of like, I try to explain it a little bit how my intuition goes. And then as a leap of faith, I'm going to put in this thing here, there. And that is a positive value. So that means if this is 0, it actually points straight into the screen. And then when this grows, it's going to point more and more left and right. And but for a ray direction to be useful, it has to be of the length 1. So a vector can have a length, and that you just apply Pythagoras theorem to the different components, and then you take the length and you divide by length. But there is a shorthand for that, and it's called normalize. So that means make this the length 1. So it then basically divides by the length here. That's what you're doing. This is probably the most complicated math we're going to do today. And I suppose it's a little bit of leap.
We're not going to do more trig.
It's not going to be conceptually as difficult, right? And normally when we do ray directions, we normally do things like, this is not the only way, but this is a short way of doing it, and it's kind of simple. Normally what you do is to set up different kind of ray, different kind of directions, and then you do cross multiplications, and then people go, what the heck is a cross multiplication, and so on and so forth, and then you construct a ray in a little bit confusing way. I think this is at least shorter to do. And when it comes to shader coding, I think you don't have to understand everything. You can sort of copy paste, conceptually understand it perhaps, and then tinker with it. At least that's what I do. And then maybe later I understand how it works. Or maybe not.
And you still end up creating some pretty cool looking stuff.
Yeah, because it's a very iterative process. When making shaders, it's not like very few people sit and think, I'm going to do some math now, and then I'm going to be very, very satisfied when the math turns out correct. It's more like, oh, this is a mistake, but it looks cool. That happens very often. Now, if you're going to do ray tracing, and just interrupt me if I, drone on.
Absolutely, you're doing great.
If you're going to do ray tracing, we need a few variables, and the first variable we're going to introduce is I, which is the iteration variable, because we're going to do for loop where we iterate a few times. And then I'm going to introduce a D variable, which is the distance. So I'm going to compute the distance to the objects that we're going to ray trace. And then I'm going to introduce a Z variable, which is the distance traveled along the ray. So first it's going to start at Z 0, and then we're going to increment it and move it further into the scene. So this is going to start with them. And
quick question then. Why are you using float for your iterator? Is it going to possibly be a decimal value?
It's simpler for various reasons.
Okay.
Because GSL doesn't allow converting. Like if I type just an example int x like this, and then I type float y equals x, that doesn't convert to floats. I have to type this. So
interesting.
If I just make everything floats, I don't have to care about that thing.
Cool.
So that is the main reason. And then I'm going to need some other variables. I'm going to use some vec4s. This is the output color. And I'm going to accumulate a color or create a color. And then I'm going to have a position in space.
Oh,
I'm going to
now that you say that, are vec4s, are all of the dimensions on it always floats?
Yes. So conceptually, if I write struct vec2 here, for example, is the concept. It is like this basically. I can't write code like this in GSL, right? But it's conceptually it's like this, right? And if it says vec4, it's 4 floating points.
Cool. Thank you.
So now I'm going to introduce the for loop, which we're going to use to sort of iterate through space. So I'm just going to write it shorter than most people write it. So I'm going to write it like this because, I'm damaged from writing. But conceptually,
I mean, you can still write it like this in C# too. You don't need to always declare.
And there's a benefit of doing this, because if I would type ++I here, but I make a typo and the loop becomes an infinite loop, then this environment crashes for me. So this is actually a bit safer to write than normally. But the idea is the same, right? We increment the variable, and then we test it against 77, and then it loops about 77 times, so maybe 76. I don't know. It's not so important. It's just a number, right? It could be anything. I just like the symmetry of 77.
And that dot that you put there is just to make 77 afloat?
Yes, exactly right. Because as I mentioned before, but it's not obvious. It would complain, but some errors doesn't show up because I'm using a version of OpenGL, the GLSL, the web version, and that doesn't do automatic conversion for you. So there are many different variants here, but in this version, I need to put a dot in, otherwise it won't compile for me. And then I'm gonna produce a point P. When I'm gonna use this ray direction, this point P is gonna be the point where we are when we are iterating through the space, so to say. So and then I'm gonna copy paste this ray direction, and I hope I did it correctly because I just typed it, and I hope I didn't mess up too much. And then I'm going to say I'm going to multiply this ray direction by z, which is the distance traveled. It started at 0 now, and I multiply by that, and that produces point P. But for reasons that I like, maybe we're going to do some 4D graphics. So I made this a 4D variable, not 3D. So I'm just going to extend this thing here with 0. So the first part here is the 3D component of a vector, and then we have a fourth dimension at the end, which we might use depending on inspiration or whatever later on. Just put it at 0 for now. So now we have a point in space. Now I want an object to sort of ray trace, and we're going to start simple with a sphere. And I don't know, people learned in school, if you remember school or whatever, doesn't matter, but all the points on a sphere are to the same distance of the origo.
Equidistant from the...
Exactly right. And what I want to construct is something called a distance field, where if I pick a point on the sphere, the distance should be 0. If I pick a point outside the sphere, the distance should be positive, meaning the distance to the sphere from that point. And if I pick a point inside the sphere, it should be the negative distance, meaning I'm inside the object. So I'm going to compute this distance here by taking the length p minus 1. And then what will happen here, for all points that are from length 1 or distance 1 from the origo, it will be 0. For all the points where this is greater than 1, i.e. we are further away from origo than 1, it's going to be positive, and negative if you're closer. So this is going to be our distance field for a sphere, if that makes sense. And then I'm going to say, if I'm really close to this thing, I'm going to say that the color, I'm going to increment the color by 1, meaning it's white. And then I'm going to go break. So sort of say, okay, we're done, we hit the sphere, we're happy. And then the question is, how now we're going to advance the ray. So this z variable, we're going to increment it, but how are we going to increment it? Well, what we know, let's say d returns 2. That means we have 2 meters or whatever from the sphere. So, okay, so let's move 2 meters again and see if we hit it or not. We could hit it depending if we go straight against it, or we could miss it, or we could even move away from it. But the way the strategy here is, we're going to move forward with how far we are from the object, so to say. So I'm just increment that thing by t, if that makes sense. And then finally, I'm going to equal O equals O, and it's all white, which is disappointing. But
not what you were expecting.
The reason is we started in the center of the screen and started traversing towards the sphere. But in the center, on the center of the universe, kind of like Origo, but the sphere is there. So we are inside the sphere. It's white all around us.
Right.
So what we're going to do now is we're going to move back the point a little bit. We're going to take the Z variable here and move back by 1. And that wasn't enough. But now you can see a circle. Not looking like a sphere so far, but a circle, which in theory could be. So we need to apply some shading to this thing here to make it look more like a circle. And there are many ways to do that, and there are complicated ways to do that, but I'm going to propose a simple way of doing this, or at least I think it's simple. And you know this I variable we have up here that we're incrementing. So we can use this I variable as an estimation on how many iterations did it take until we hit the sphere. And we can use that thing to generate a color. So the fewer iterations it takes to hit the sphere, it's going to be, you will see probably, you will get it. So I take I, okay, it's all white, but if I divide I by 20, you see now it starts looking a little bit more like there's a lighting effect here. And you see at the edges, it's whiter, and in the middle it's darker. And the reason for that is when we're moving straight at the sphere, not at an angle of the sphere, we hit the sphere quicker. And then as it moves out, sort of the ray gets closer and closer to miss it. It needs more and more iterations to hit it. I.e., it gets more and more white. So this is a very simple technique to generate a shading for us. But obviously, to make it a little bit, I think it looks nicer if I sort of inverse the color scheme, like so, because then it looks a little bit like a sphere that is
actual sphere.
Straight ahead, like I'm holding, I don't know, a lamp or whatever at this point.
Or a flashlight straight at it. So
maybe I'll move this thing away here. Yes. So, okay, so we did the sphere. And this is actually ray tracing, right? If that makes sense. And it's not that much code to get the ray tracing going, but it's a little bit boring so far. So, a sphere is good and all. It's a good thing. And you can make interesting things with spheres. But I like cubes. I think when I grew up, computers really are made to rotate cubes. Cubes are cool. Spheres are cool too, but cubes are cooler.
It's the first thing I learned to do with OpenGL.
Yeah, exactly right. So how we can make a cube is we compute the distance field for a cube or for a box, and that's possible, but it's a little bit complicated. I think that math. It's not very complicated, but I can't really do it from my memory. But what I can do is change the sphere into something called a supersphere, which looks more like a cube. And then people go, well, what do you mean? I don't know if anyone knows that, but maybe people go, what the heck is a supersphere? So you might remember that the sphere equation is a little bit like this. So for all the points, and we have the radius 1 here, right? So for all the points here, where this equality is satisfied, we have the points on the sphere. And this is essentially the distance. If you take the square root out of this thing, this becomes the length or distance. This is what this thing is doing. It squares all the components and then take the square root out of it, and then it computes the distance or radius of it. So that's a normal sphere. But you can actually do this, pi by 4 instead. And what does that mean? What happens then? Well, then you get something that looks more like a cube. So what I'm going to do now is I'm going to, instead of doing squared, I'm going to do powered by 4 instead. So in order to do that, I need a helper variable here, p. And then I'm going to take p equals p here. And then I'm going to multiply each component with itself. Because p contains x, y, and z, but I want to contain x squared y squared, z squared. And the way I do it is I just multiply it by itself, like so. So now it contains this thing. And to do the final step, I'm going to do the dot product. What the dot product does when I type it like this, it multiplies each component with itself again. So now each component goes from x squared to x powered by 4. And then it adds it all together. That's it also dot function does, so to say. So it does, since we are at x squared, we then end up in this form here. And then I'm going to take then the square, and then I'm going to remove the power by 4 by taking the power of 1 divided by 4 to remove that part of the component, to remove the thing. Normally we take the square root, but in this case, since we have gone up by power of 4, we have to do the 4th square root to remove that thing. And now if I haven't messed this thing up here, let's see, we have something that looks a lot more like a box.
Ish. A super box. I mean, a super sphere.
A super sphere, or a box, or a cube, whatever. So, okay, so that's okay, but what we're going to do now is we're going to rotate the box to be able to see the boxiness. And there are different ways of rotating, but I'm going to introduce one of my favorite tricks lately that I learned.
It's called turning your head. No.
Yes, kind of. But inside the shader world. And I'm going to introduce something called a rotation matrix. And that is, so a vector is 2 floating points. A matrix is 4 floating points. That's all it is. But the way then we can multiply this rotation matrix with the vector. And that is done in a special way, which is just based on certain kind of math. It's not very complicated, but I'm not going to go into that. But I need to prepare this rotation matrix in a special way to sort of make it rotate. So the way I'm going to do it, this is a 2x2 matrix. I can even type this. So in case it's a 2x2 matrix. And then I'm going to initialize it. And I don't know if you know this, but some people, you did some OpenGL. So you might know that
like in 2000, but yeah.
Rotation matrix initialize something like this. You take the cosine, the sine, the minus sign, and the cos, right?
I do recognize this. I wouldn't have been able to come up with that off the top of my head, though.
Yeah, but it's a little bit too much to type for me. I'm too lazy. So I learned a new trick, which I love, is to create an approximate thing here, which looks completely random, but that's okay. So instead I'm going to write it like this, which is essentially the same thing. But don't worry about how it works. This guy actually can explain, but this is just a pattern I learned how to do a rotation matrix. And now when I have this matrix, I'm going to multiply the x and y component with this thing. And then it multiplies this thing here in a special way, so to create a rotation. But it's not rotated, so we'll be all very disappointed. But the thing is, I need to put in an angle here, right? And now you see I'm applying a rotation. Like so. And I can even multiply by the time component here. And we have now a rotating cube. Well, it looks like a square-ish, but it is a cube. And the way we can finally see the 3Dness, because we've been working towards the 3Dness now for a little bit while here, is instead of rotating xy component, I'm going to rotate xz component. And now you can see maybe that we have a 4D cube, not a 3D cube, what I mean. Make sense? I hope.
Yeah.
And we can also make the rotation a little bit more interesting by also rotating it in
there it is.
XY. And now
this was my senior project now. This was pretty much the thing you had to do to pass the class.
Yeah, we did it in a few minutes.
Yeah.
So that's the thing. So maybe you should. Do you have any questions or thoughts or whatever?
I asked the questions that I had while we were going, but if anyone else in chat does have, well, I guess Marcus Voice Coder did ask when you had the first circle with the dot in the middle. Are we about to do James Bond? So, can you do a circle that looks like the spotlight from James Bond go across the screen with the swirls? Do you know what that looks like?
I could. But I was thinking going in a different direction.
Okay,
that's okay.
Please do. Absolutely.
So this is cool and all, perhaps. We can also do, I mentioned this is 4D, so we can actually do some 4D rotation, just for fun of it. So I'm going to put in the W component, which is the 4D thing here, right? And then I can say, I'm going to flip this around here. And now we have a cube. And people go like, well, what does that even mean, right?
It's something to help you expand your consciousness.
Yes, but this can be a little bit tricky. But I thought a little bit of
to
way to
conceptualize.
This,
yeah.
To conceptualize. So imagine you have a 3D cube, and you have what you do is you take a 2D plane that intersects that cube.
Visual ASMR.
Right? That intersection, depending on where you do it and what angle it has, is going to look differently. It's still a cube in 3D, but it's going to look different. So if you do it straight on, it's going to look like a square. But if you sort of rotate the plane, it's going to stretch out, and then it's going to be, and it can sometimes become a triangle, and it can be more than 4 squares, depending on exactly this thing here. We're doing kind of the same thing here, is that we have a 4D shape, and then we take a 3D intersection through it, and then we rotate this intersection through the space, which then creates a kind of weird rotating moment.
Yeah, I hope that there are people in chat that are maybe thinking about this a little harder than they should, because this is already something that I've explored a lot of, exploring what higher dimensional shapes would look like in 3-dimensional when they're projected into 3D.
So, yes. Yeah. So you're in a good position. I just think it's kind of cool to do it. That's the only reason I do it. So I don't think too much about this shader world, which the reason I like it is very explorative. You try things, and if it looks cool, okay, that's enough. I don't have to understand everything. If I understand it, that's okay, but I don't have to. I don't put that sort of on myself to understand it. But I want to show you another thing, and that is what's better than one cube? Lot of cubes, right?
A triangle. No, I'm kidding. Yes, yeah. Lots and lots of cubes.
Lots and lots of cubes. And one way to do lots of cubes is doing a for loop, but that takes more iterations. And even though a GPU is very, very fast, this program is run for each pixel on the screen. It's 60 hertz. So even though the GPU is fast, we don't have infinite amount of computation power. So, but there is a very nice trick here. I'm going to talk a lot about tricks here, but shader coding is a lot about learned tricks, so to say, right? That you sort of pick up over time. So the first thing I'm going to do, I'm going to reduce the size of it a little bit, because otherwise I actually increase the size. So I make it a little bit smaller. And now what I'm going to do, conceptually, is I'm going to take kind of the unit box around the cube and repeat it infinitely. So what I'm going to take this cube here, and I'm going to sort of duplicate it in all dimensions infinite amount of time. And how the heck do you do that? Okay, yes, that's cool, but okay, what does it take? But because the way ray marching work, this is what it takes. So what round P does is what you think it does, or maybe some people think it does, is that you round each component X, Y, and Z to its nearest integer.
Whole number. Yeah.
And then we subtract that thing from the position P. Remove that part. And it goes all white. But the reason it goes all white is because we're now standing in the middle of one of the cubes again. So if I move back a little bit here, that wasn't good. You can start seeing there's a cube in front of you here, and a lot of cubes at the side.
Yeah, this looks like you're inside of a bloodstream or something now.
Yeah, kind of. And but I can move this thing to the side here, like so. And now we can see we have lots and lots of cubes. I think we can see even more here by doing like so.
Marshmallows.
So lots of cubes. So this could be, I think, possibly surprising. One cube, lots of cubes.
Yeah. It's
one
insane.
cube. It's kind of insane, right? And
Yeah.
I like it. And I can explain it. It's much easier to understand this in 2D. It's harder to understand this in 3D. But it's called domain repetition. So we kind of if we have an object, we can repeat this object. Well, it's learned. TBT gamer. This is a skill that you learn, like everything else. So it looks magic, but I didn't come up with all of this. Obviously, I just learned from others.
Yeah, but
stole
you're
ideas.
applying it in a way that only you could apply it. And it's really, really cool to see.
So now let's move along this space here. So what I'm going to do now is I'm going to move. Instead of P said, I'm going to
an earthquake.
So now we are traveling inside our little world of cubes.
We're almost inside of a tesseract.
Maybe. So thinking about here, how could we spice this thing up? Because I was, okay, this looks cool, but let's make it more interesting. At least I often, that's how I think about things. So what I'm going to do here is I'm going to introduce a second rotation matrix, which I'm going to call W. I don't know why. I just call it W. And I'm going to multiply P.xy with W.
That is one of the biggest questions I've always had about shaders. Is the reason for small variable names because
it's just me that is lazy.
of memory?
Yeah, right.
Or, okay.
No. It's just that I got into a habit of writing small shaders. But here's a tip, right? If you have a shader which is completely indigestible and weird names, put it into AI and ask it to comment it and give it better names. And it does a pretty good job on it.
Cool. Plum Tardigrade wants to know, question, and forgive my absolute lack of coding acumen, is it possible to have each blob a different color?
Yes, we will actually coming to that thing. And there are different ways to do it. But yes, it's definitely possible. And we're going to change the color. We're going to spice up the colors a little bit because it's a little bit gray and dull right now. But before
I like gray and dull.
Yeah, sure. I want to make the rotation a little bit more, at least I think, interesting. So instead of rotating by time here, what I'm going to do now is I'm going to rotate depending how far we are inside the scene.
Oh, he was trying to hypnotize us.
So P.Z here, Z variable, is how far have we traveled inside the scene. Does that make sense? So P is our ray traced component, and the Z component here is kind of showing how far we are inside along the Z axis, which you see. So now I'm going to rotate this thing here like so, and now we get a little bit of spiral shape here, which looks, I think, a lot cooler, just like that.
Like even this, it looks like the animation style of Hollow Knight. Is that the name of that black and white game?
I'm not sure. Hollow Knight, yeah, maybe. I haven't played it, and I haven't either.
I've just seen it.
I'm going to replace this W with this rotation here. So this now, all these cubes are now kind of also rotating depending how far we're in. So the cubes now look a little bit different as far as when we travel into it. This looks like a cube, and this looks a little bit more round, and this looks a little bit more shapy. So it's just to sort of spice it up a little bit.
Spice it up, yeah. I had to look this up, but it kind of feels like we're inside of Shai Hulud's intestines.
Maybe. Yeah, Shai Hulud's body. Yeah, we're being digested by the thing. But so far, we made a ray tracer.
I had a nightmare like this as a child, says TBD.
Yes, Shai Hulud.
Medical science applications.
But maybe if we can add some more color for you, TBD, maybe it's get more happy-go-lucky. I don't know. So, but so far, it's not that much code. The code is a little bit weird, but it's a for loop. We know about that. This is the ray direction, which we talked about, which is a stretch to understand, perhaps, but it's a ray direction. And we multiply by the Z component, which we travel inside the scene. And then this thing here makes us move along the Z axis in the scene. So I just multiply by I component. And then I have this rotation matrix that depends on the Z variable. And then I rotate by that, and I do this offset here to sort of, move around the center. This is probably another one of these, how the heck does this even work? One cube, no cube. Now, when I do this, the cube is outside the screen, the original one, and then I repeat the cube.
Because we've already moved away from it.
Yeah. And then we apply some forward rotation, because why not? And then we create this supersphere, as we discussed. But the coloring is very simple, so I'm going to complicate the coloring process to make the colors, I hope, nicer. So I'm going to introduce another of my favorite tricks. A lot of favorite tricks here is how I'm going to compute the color using a palette generating function. So a palette generating function produces nice looking colors from like a floating point. And there are different ways of doing it, but this is one of my favorite ways of doing this. So I'm taking one.
And just to be clear, you're saying palette for us Americans?
Yeah, I don't know what the correct word is, but it's
that was
it's
right.
a range of colors that looks nice.
Yeah, a color palette.
And I'm going to save this. I'm going to save this P component here again. So I'm going to save it P here, because I'm kind of destroying P with all these operations I'm doing here. So I'm going to save it here. So I introduce the vec4 to save it, right?
Oh, as far as like your so this isn't a reference then. This is like copying the value of P like a snapshot on line 49.
Yes, they are like structs in C#. And then I'm going to take that value there, plus, and this is going to look random, 0, 1, 2, 0. But what this thing here does is that it takes this sy variable, and I could type it in here like so. And not I want to type Z, not Y, or Z, right? I could do that, but if I type it like so, this is what it does. It adds these two components together, and this thing here becomes then a 4D vector. And then the sign operation here, we take the sign operation on each individual vec4 component, so that we create sine waves that go in different phases. I mean, they're going to be slightly off. A sine wave goes up and down in a smooth pattern.
Oh.
And the sine function goes between -1 and 1, but -1 is not good for colors. So I'm adding 1 to it. So it goes between 0 and 2. And also, give me a second.
Oh, yeah. This is insane, isn't it, guys? Cheapers.
So this is, so you have to trust me that this generates colors, and you're going to see this soon.
No, I can absolutely picture it.
Yes. And then I'm going to comment out this old code here. And what I'm going to do now is what they call a glow tracer. So what I want to create is a glowing kind of effect around these cubes. And the way I'm going to do it is we're going to add, I'm going to use the alpha value. This is the alpha value. And then I'm going to randomly divide by D. It's not random. But
I love how everything is random though.
But D, the closer we get to object, the smaller D becomes. And when we divide by something small, it becomes bigger. So the idea here is the closer we get, the more intensive the color becomes. So it will create kind of a glowing effect around these objects. And then in order to avoid division by 0, I'm going to take the maximum value here, so we don't divide by 0. It doesn't crash by dividing by 0, of course, but it's not going to look.
You said of course, but that is surprising.
No, well, if you take a floating point in C# and divide by 0, it doesn't crash.
I didn't know that. Yeah.
It returns, depending on what it is. If you divide 1 by 0 in a floating point, it returns infinite.
Oh,
and
right.
if you divide 0 by 0, you get not a number, but it doesn't throw.
Okay.
So there. And then finally, I'm going to multiply this by this color P. And we see nothing.
Glowing marshmallows.
But that's because all the colors are too intense to see. So what I'm going to do now is going to introduce one of my favorite functions. And then I'm going to divide this thing by 1e3. So the problem was the problem is the values were too big. So I need to sort of find a value here. And here we see that this graphics card is a little bit, it's not very good because it is not supposed to look like this. It should be still white. But if I get here, we start getting to sort of a value where we can see the different colors for different boxes. And the color changes here, right? Depending on these
those purple ones look tasty.
Distances. So if you change like this, 0.5, it doesn't change that much. If I do that like this, it changes quicker, so to say. Now, another thing that I like to do, right, is I think it adds to everything by making things translucent. So because now they are solid, but I think it looks cooler if they are not solid, they're kind of translucent. So
a little glass.
How do you do that? How do you do that, right? Well, the approach here is what happens here when we are traveling through the scene here is we get closer and closer to object. And when we're getting really close to object, we don't get any further because the distance goes to 0 and the ray gets stuck there. So what I'm going to do here is I'm going to say that, well, I'm going to increment by one small value, like so.
Whoa. I liked it, the brown. What was that?
That is a benefit when you just when you type code like this, you get weird stuff. So sometimes you see things that looks cool, right? Okay,
Yeah.
so that's a bug, but you might like it, and then so that's why I think it's so important that it continuously recompiles, because you never know that the typo could actually look good. And I have a few of these cases when I did a typo, and it still look good. So what I'm saying here, if D is close to 0, well, let's step forward a little bit anyway. But the problem is now that it's not inside these super spheres, it's a negative value. So what I'm going to do now, I'm going to make conceptually these super spheres to like soap bubbles, where the skin is very, very thin, but the inside is still kind of outside the skin of the soap bubble. I don't know if that makes sense. But so the inside of something is negative. But so how do you fix that? Well, it's very, very simple. Maybe too simple sometimes. I'm going to take the distance to the object. I'm not sure why this. No, I'm pressing the wrong button here. There. And take the abs value, meaning all the negative values are now positive values, meaning there are no sort of insides anymore, except a very, very thin layer. And now it looks. You see it translucent now. You can see through the objects. So I think that's
awesome.
But now what you might see as well is we have like these flickering artifacts here coming.
Yeah.
And the reason for that is when we are doing these 4D rotations and these kind of things, we kind of are really messing with the distance field. So what happens is we overstep sometimes. So we are actually hitting, we are never supposed to hit inside the object when we do it, but because we have sort of distorted the distance field, we overstep sometimes. We travel too far. But that's actually a very simple way of doing that. We just multiply by something here. So, okay, so the distance sometimes is too long. Oh, well, let's multiply by something that is less than 1 then. And now the artifacts are beginning to disappear.
Marcus gave me an idea to try these glasses with it, and it's making it 3D. It's like actually coming out at me. That's crazy.
Now you can see it's sort of translucent, and there's translucency here that we can see through the objects, and there are different kind of colors as well, right? Once again, it's not that much code, right? So far we have written in it, and there are some magic code here and there, but some of the things I think is possible to understand, so to say. Some of the things might be, I don't know why this works, but it doesn't matter. There's a pattern. Now, I want to spice up the color a little bit here. So there are different ways of doing that. One thing, we can take this length component here and take the XY component here and add it to this thing. And now what will happen is the color of the screen depends on the distance from the line. So we travel along the z-axis here, but then we take the distance from the z-axis and sort of color it. But when I do an experimentation before, I think this is probably a simpler way of doing it that actually looks nicer. You just take the X component here, which is being rotated, and this creates kind of a spiraling thing of the colors.
A spiraling gradient.
Yeah. And then you just, and then what you do, then you start this process, which value looks the best. And this is where you don't think. Let's not think, that hurts. So what you do is you try different values until you start thinking, I like this the best. I don't know which one you like the best. I kind of like the 5 one.
All of them. So Tardigrade is asking, is it possible to have waves of color, as in the colors transitioning along each strand? So like as you're moving along, the colors are also kind of flowing through the strands. Like a pulse wave.
Okay, I see. Well, what we can do is we can...
Did I get that right, Tardigrade, by the way?
I'm sure that is exactly.
Oh gosh.
What we can do
yeah, that
is
I think that's it.
we can animate by the time, right? So now the color, we animate everything by time here.
Wow.
So, and speaking of pulse here, maybe we should, sometimes I like to make, well, first maybe I should stop a little bit and see if there are some thoughts and questions from you.
There was one more question that I would like for you to repeat. You said at the beginning what this application was and what other ways you can start doing this, but who was it? Zerg was asking, how do you get into doing shader?
Well, how do you get into? I think joining the Shader Toy community and start looking at shaders that are not too overly complicated. And we can talk a little about Shader Toy later, but Shader Toy is a great community, I think, where you can, there are lots and lots of shaders on Shader Toy, and some of them are really complex, but a little bit like, what is it called? The Library of Babylon, or Babel, I don't remember the name.
Tower of Babel?
It's a library that you,
oh, okay.
This library contains every knowledge there is in the world.
Oh, okay,
everything.
Yeah.
But the problem is finding it, because it's an infinite library, so to say. So you find all gibberish as well. And the problem with Shader Toy is so big, right? So, but there is a shader there that you can conceptually understand. And what we've gone through here is, on Shader Toy, a lot of the shaders are ray marcher shaders. So what we have done here is something called ray marching. We have chosen a quite simple way of coloring it that still looks nice. Just because it's simple doesn't mean it doesn't have to look nice.
Yeah, of course.
But this concept of creating a ray direction and then travel inside the world is what 90% of the shaders on Shader Toys does. So this kind of, they have a different kind of patterns here, but this kind of concept is what they do. So I would say checking out Shader Toy is a good way. I can probably find some links to some blogs that got me started in the beginning on how to do it. And I'm kind of hoping maybe if people watching this is like, yeah, maybe they can ask me some questions in the one-line chat if they're curious about this, and I can give some tips. You know, I don't mind these things if you're interested in starting. But honestly, I think looking at shaders, stealing ideas, you know, and don't get hung up on, I don't understand everything there is to this shader, because there are a lot of lucky accidents. So one of the things I struggled with in the beginning with Shader Toy was, I looked at a cool looking shader, and there was a constant there like 0.37. And I go, how did they arrive at that constant?
Oh, right.
What was the mental process? You know, what was the math? That was how I thought. But now I know how the process is. This guy or girl tried 0.2, nah. 0.3, nah. But better. 0.4, okay. 0.5, worse again. Okay, maybe the value is between 3 and 4 then. 0.3, okay. And then people do what I do here. They iterate very quickly with these colors and these values until it looks good. So sometimes there is thought behind it, but very often it's just, I tried things, and it looked better than this thing. So I think don't overthink the shaders, so to say. There are the ideas that are general, like the ray marchers, but then there are this coloring and these things. It's kind of just
They merge.
intuition and randomness,
Yeah.
and a little bit of math. Well, I don't know if that makes sense to the person asking
Absolutely.
questions.
I mean, at least to me, but definitely each person in chat, if you do have something you want clarified or you just want to respond to that, please do. But it certainly makes sense to me.
Yeah. So yeah, because there is math here, obviously, and that's I think one of the problems with shaders are that they are a little bit mathy, so to say. But this math, I think, you don't have to understand everything, especially when you start. There's some things I don't understand. I don't honestly understand exactly how this thing works up there, but I have an intuition for it, I would say. But I'm not so bothered because it looks okay when I'm doing that. I learned this pattern, and sometimes for most of the things you just try things and you develop this intuition of things, so you can sort of more and more have this thought, yeah, I can sort of kind of predict where I'm going, but let's see what happens, because the best shaders I ever made kind of arrived from a mistake.
Yeah.
So I was trying to do one more thing, which I think this person asked about wave could maybe
Absolutely.
find liking.
Please do.
And that would be to introduce some kind of beat to it, because I like to sort of synchronize shaders with music.
To music. Awesome.
Yeah. So we'll see if I manage to do it. But what I'm planning to do is introduce kind of flash here into it. And this flash and the movement in the shader should then be beat synchronized, so to say. That is the goal here. And let's see if I succeed. So the way I'm going to do it is, how I'm going to produce the color? Well, I want over here, in the middle, I want there to be a flash effect. And okay, how do I do that? Well, I know that the ray here, because the ray stops here, it doesn't travel far. So here it traveled the furthest. So I'm thinking I will use the distance traveled to produce a color. So the further I've traveled, I want the color to be more intense. I'm not exactly sure how the formula going to look, but I'm going to start with that thinking. So the first step is increment by Z at all, but that didn't work. So if I go Z by Z, now, okay, so maybe that's the value. So
and it also kind of looked like, just because of the way the the shading is appearing in the distance, it kind of looks like the light is warbling a little.
Yeah, yes. And we can remove what we can do is we can remove these cubes here, so we can just see the light here, so to say. So we can maybe look at that. So, and then I want some colors. So I'm gonna pick some colors here. So I'm gonna use this 1, 2, and 3 scheme again, because I like that. So let's not think too much about it. Something like that. Okay, and I think it's a little bit too intense, so I'm gonna divide by something. Okay, maybe that's good. Yes. Okay. So I'm dividing by something to sort of find something, and then we can experiment with these values here. Now that's too gray. Yeah, maybe that's okay-ish. What about this thing here?
Those are my
favorite
favorite
preference
colors.
of color? Yeah, you are kind of purple, right? Right. So we're gonna go purple. So these are the RGB component, which I then multiply by this Z value to produce this produce this color. Maybe I'm gonna try to. What did I do there? Multiply one more time and then divide by something bigger. Maybe that's a good idea. So then, because each time I multiply, it gets more intense, but at the same time, the light doesn't spread as much, if that makes sense. So if I go here, for example, the light kind of spreads more in the seed. But the more components I'm adding here, the light gets more intense, right? But if I divide by this thing, I get less spread of the light in the scene. So I kind of like that. So I want some spread of the lights, but I don't want too much of it, because it's going to make the graphics look desaturated, and I like saturation. I also, let's see how it looks when we add this thing together. Okay, so now we have a purple light in the middle, And now I want to add a flashing effect to this thing here. So, so the way I'm going to do it is we're going to compute the time a little bit different. So we have this time variable here. So I'm going to introduce, I don't know what's call it. I'm going to write some longer names here. I'm going to call it beat time. So this is the time that we're going to adjust for the BPM, so to say. But let's start with just time here, right? And then I'm going to compute fract time here, which is the fraction of the beat time. So what fract does is you might know what floor does, right? Floor throws away the fractional component and you keep just the integer component, right? Fraction is the other part of it.
Keeping everything after the dot.
Yeah, and then I'm going to say, and I'm going to write the short variable, I'm going to call it t for time here. And I'm going to say this is floor beat time plus fract time. And then you might thinking, but that doesn't do anything, because here you remove the floor part and then you add it all together, and that's correct. But I have a plan, you see. And then I'm going to remove this time here. I'm going to find all places of time. I'm going to replace them with t. Yeah, not that one though. And now what I'm going to do, I'm going to multiply this thing by the fract time as before. And you see what happens. I'm just going to look here at this thing. So now the light pulses. And the reason for that is because fract time, when it starts, it goes to 0. And then it increments up to almost 1. And then it goes to 0 again. Because we are throwing away we're just keeping the fraction part. But I think it flashes in the wrong direction. So I'm going to go this direction. Now it's like if you can imagine a beat time, so to say.
Absolutely.
And now what I'm going to do here is, in order to make it a little bit more pronounced, this beat time, I'm going to take the square root randomly, as I like to say, out of this beat time. And that didn't tell you, but what this thing does is that we see it better when I add all animation together. Now you see the scene like speeds up and then slows down, speeds up and slows down.
Love that.
It speeds up with music, right? And I don't know what BPM you prefer, but let's say I have a music thing on that has 114 BPM. So what I'm going to do here is I'm going to divide by 60. What did I do here? I need to say now. Divide by 60, hopefully. Very, very slow. And then I'm going to multiply by the BPM. Like so. And then I'm going to say the BPM here is 114. So now we have a 140 BPM. So then, depending on the music you have, it's very simple, right? So you measure the BPM, and then you just say, okay, I have 120 BPM, and it boom, 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 like so.
And somehow pass that in as a variable for the song that you're listening to.
Yes. You can do like all uniforms to send in shades. So now we have a flashing light here and a movement that kind of moves with. And I kind of, it's something, right? So that's perhaps a little bit cool. I don't know what you think.
I love it. Absolutely love it. Zerg is asking how translatable. I'm going to interpret it like this. How translatable is this to HLSL?
Yes. It's very transferable. HLSL and GSL are both very hard to say, these names. Mm-hmm. It looks better on my other screen, by the way. Better colors on the other screen. So on that looks crap. But so answering your question, it's very much the similar thing. It's even kind of hard if you don't know if it's GSL or HLSL, if it's the same thing. But for example, in GSL, HLSL, DirectX version, it's not called vec2, it's called float2. Like so.
Which is pretty much
the same. There are some other differences. Some functions works a little bit different. Some function, there's a function called mix here. That's very common. I haven't used it today. It's called lerp in HLSL. And there are some other things. So what I actually done, I made this small, I won't call it library, but small set of functions and macros that I can paste into a GSL shader, so I don't have to change the code, or more or less, and then it's compatible with HSL. So I just made some small functions that kind of help me cross that bridge. So it's very similar. Now, at least the language. Then in DirectX they have these things of, I don't know what they call it, but you have like these semantics of that works different, right? But I would say if you know GSL, you understand HSL without any major problems. If you know, and vice versa. What's annoying, because this brings up one of the things I don't like, is they introduced it, which is called Web GPU, which is the next version, the future for web GPU development. And then they introduced a new language, which is called VGSL, and that's kind of some stupid Rust in syntax. So I like the part that you could basically just port these things very easily between themselves. But now, no, we introduced some kind of new.
Let's give you a brand new
language for no reason, I think, because the things that Rust gives you, you have no need for it here in Shadyland. It doesn't add anything. So they just introduced this new syntax to break. I don't know why. I don't show off or something. I'm annoyed. I think this C-like language is perfectly good enough for shader stuff. And so I will not go on a rant. But yes, to answer your question, very much applicable.
Short answer is yes. And then Tardigrade wanted to know, is there a way for you to progress through the scene to do your Z marching independent of the flashing light of the pulse?
Yes, you could. I changed this from T to I time. Now
Right.
you see the flashing light and the thing.
I love this. Oh my gosh, it's so cool.
So, but now you see this rotation of the things moves like that, right? But what I want to do, the last thing now here, I think we can wrap up a little bit here perhaps, but I hope at least people here thought it's a little bit interesting at least, and it's not.
I mean, I'm sorry, I'm only the host and everyone else is out there and I'm like, just keep talking. This is awesome. I want more.
Yeah. So, but I hope at least, okay, that we did some make-believe math here at different, multiply by this, at different situations, right? We did a few things. We constructed the ray direction. We did this random round thing in the middle of it, right?
Mm-hmm.
You know, it's some of these things are just easier to explain in 2D. But I think for the other part of the code, if we commented it, and we use Claude to comment it, and we get better variable names, it would help in thing. But just to sort of wrap up before I'm going to move on to the last part here. So we have this loop here that we're iterating through the world. So I can actually change this thing here to 37, and then you see we lose a little bit of fidelity because we're not traveling as far into the scene. And I can also go up to, I don't know what happened there. I can go up to 117, and then this gets more, and you start seeing the frame rate drop because my screen can have, it looks kind of cool though. But, so this is just saying how many times we iterate for on each pixel. And here's the make-believe math to create the ray direction, which, yes, whatever. We multiply this thing here with the Z, which is how far we travel in the C to produce the point P. And then we move the point Z into the C. We create a rotation that depends on the point Z to create a spiral motion. And then we multiply this rotation matrix. And this is also a little bit make-believe, right? But this creates a matrix which is used to rotate things. And this is the angle. And then we multiply the XY component with that. And then we take a backup of this thing here, and we do a little bit of adjustment. And then it's the round trick. And then we do a forward rotation of these cubes to, hopefully make them a little bit more interesting. In some sense, maybe, or maybe not. But that's the idea. And then we create a supersphere, which is x powered by 4, y powered by 4, z powered by 4, by taking the backup of this component, multiply by itself, take the dot product to create this final sum, and then 4th power of square root out of it. And this is the radius-ish of this supersphere, right? And this creates a distance to the boxes. And then what we did, the apps thing we did, that's sort of to make sure that the inside is also the outside. So when we travel along the array, we don't get stuck. When we get through the layer, we still travel through the inside of it. And this creates this Sopal bubble-like thing. So if I remove this thing here, right, the transparency will disappear. Which it also looks okay, I think.
Looks cool.
But I just think this looks better. And then we have the classic formula for generating the palette. This is kind of a classic formula, and we can do different things that we can do. And maybe it becomes better. We can do like this, this, and this, and that looks okay too. And then we can do maybe this. I like 6, perhaps better. So this creates different kind of colors for us. So we can experiment with this thing here to create different kind of palettes. So there are many options that looks okay, but let's keep the original one. But this thing here creates the color, the base of it. And then we create this kind of glowing thing in this thing, and that we use the distance. So we divide with the distance. The closer we get, the more intense the color gets. And there are different things we can do here to make it glow more or less. But this is the simplest way of doing it, or a very simple way of doing it. And then we create this flashing effect, and we can see this thing. If I remove this graphic, I just keep the flashing effect. By using this fraction time and multiply by color, that is then growing by the distance, so to say. And then we divide by 111. And why 111? I tried a few others. It's not like I thought a lot about it. It's like, this works too, right? So maybe that is good. But I tried a few different options, and 111, that works. So you experiment until it looks nice. One is obviously not good enough, so to say. Maybe you like that. It's maybe you like that. Do it, right? But I like this better. And then we travel along the array. So, and the reason we multiply by 0.6 is we have some artifacts when we are rotating and distorting the distance field, without much thought about it, and that creates artifacts. Then the problem is we travel too far into the scene, but then we just multiply this distance by 0.6, so we travel shorter. And then we add a little bit of distance to make sure we don't get stuck at the surface here. We can see that if I do this thing here. Now it seems the transparency is lost because I get kind of stuck on the surface. So if I do this thing here, I can step through the surface, so to say. Because even though the distance is very small, I still step a little bit here. And then finally, the color is, I divide the color by a big number because it was too big. And how do you define this number? Well, it's kind of look cool too. Okay, that's often the case. You try different values. Actually, it wasn't too bad. But you try different values, and then you pick something. I like this the best. And 10H is a little bit, it's experience. This is another one. So what 10H does is, if you have a function that goes between minus infinity and plus infinity, it squeezes that function into minus 1 and 1 in a nice way. So it just I think makes the color looks nicer. But it works this way as well. But I like it. Experience. That's the shader. Does it make sense?
Absolutely.
So the last step I'm going to do is, I think we're going to publish this to ShadeToy, which is the site I talked to.
Yes. Very good. We definitely want to see that.
Our amazing shader thing. So now I think I need to change. Hopefully I don't screw things up, but I'm going to switch.
Stop the stream. Yeah, I think you might have to stop the stream and then restart it as sharing a different, if you did it for a specific window.
Let's see if this works. I'm gonna try here. So here I click
like a wizard saying, and that's how I do it.
Do you now you see ShadeToy?
Yeah.
So I'm gonna click new here. And hopefully, because I have kind of I'm going to copy the source code we have here into this thing. And hopefully, because I have kind of made sure that the shader language I have is compatible. Now it complained. Yeah, okay. You see this? Yeah. I forgot a dot there, right? So,
okay. Yeah, so it's like I can't convert an int to a float. What are you doing?
And we're going to give it a name. Is that good enough for you? One line shader stream?
Works for me. Whatever you want to put, it's your art.
And I'm gonna write. I also do this. Shader created during one lion's Twitch stream.
Works for me.
To hopefully help people.
I would say encourage people
to hopefully
try.
Try shadering. I don't know if that's a
Yeah,
thing.
I love it.
And then there, we need to put it here, right? So, but
look at that, still at 60 FPS.
Amazing. And this video card is not very good. I'm gonna need a tag here. So I'm not gonna publish it, write it. I'm gonna publish it, but when first I'm gonna save it. So now it's saved. And now I'm gonna pick some music, and I believe I did this before. So there's a music here called The Most Geometric Person, which I painstakingly
let me turn the other one down
to 114 BPM.
Nice.
And then
it's magic.
I'm going to use the channel time here. So what channel time does, it's just an input variable. But what this thing does here is that it picks the time from this
from which channel you decide, which is the audio channel coming in.
So if someone here comes here later, what you might see,
Gosh, that was cool.
When you come later is if you see it doesn't move. If you go in here later, the reason is that web browser can't start music unless you interact with the page. So if it doesn't move, what I typically do is I click this a few times back and forth like so. These controls, and soon later it starts. And ship it.
I bet.
So
rave mode unlocked.
If you go here now, you should see the one line in shader stream here on the latest contributions.
Like right away. Jeepers. And you just did it. You're like, this isn't a thing. You don't need to be worried about that.
No, I don't care what people think. Most people are very nice to me. I got a lot of people. There are some people that really likes what I do, and there's some people that don't care what I do. But the people that don't care what I do, they don't say anything. So yeah, you can click that thing there.
That's awesome. It's so cool.
So that's kind of what I wanted to show today.
Well, you can't hear me clapping because Crisp is blocking all of the extra sound out, but man, that was awesome. Thank you so much for showing that to us.
Any questions that I should
So I guess your screensaver is really boring, asked Marcus.
Yeah, it is very boring. But I had the idea that I should make some shady screensavers. Yes, the software I use is called CodeLife.
And you said that you could also use Visual Studio Code. Do you know if there are like GLSL
I think
extensions?
you can, but I never use Visual Studio Code.
Okay,
personally. But there are probably some shady plugins in it. But CodeLife you can download, and as I mentioned in the beginning, you click here. And it works on Linux and Mac and iPad. Yeah, so it's free to use. But if you haven't paid for it, they will pop up a screen for 10 seconds saying, maybe you should buy it. It's up to you. But then it's nothing more than that, right? Which I think is fair, you know.
Absolutely.
I bought it because I think it's good.
Yeah, and you want to support the people.
And then, but Shadetoy it's very possible to use Shadetoy to develop shaders in. When I started, I didn't know about CodeLife, so this was the tool I used. And you don't have this real-time thing, but you just hit Alt-Enter to recompile it, and it's immediately deployed to you. So it's if you don't want to install anything, ShaderToy is good enough, and there are lots and lots of examples on ShaderToy. Huge amount of examples, and the problem is, of course, that most of them are quite complicated, but there are simple ones that you can find. There's another site which unfortunately isn't very popular, but I think is really nice looking site. It's called Posh Brolly, which I can't log in here, yeah, because it's. But I published this thing, so this is my shader. So
Nice.
it has the same thing, but it's a little bit neater user interface, and you can rip YouTube music, and yeah, so on and so forth. So it's
So
really,
you
really
did
good.
do it so that it can actually hear the BPM.
Sorry.
You can wait. You said that it can use music from an external source.
Yes, and this has a BPM. This has a BPM detection built in,
yeah.
so you can actually.
All right, that's what I thought
and,
you said. That's what I thought you meant.
Yes.
Cool.
And also ShaderToy, by the way, I don't do it in this thing here, right? But you actually can get access to the sound wave. So there are a lot of shaders that do music visualization, where they access the sound wave and also what is called the frequency domain. You know, you can do, yeah, you know, like VU visualizers with different frequency, and I've done a bunch of them, but they stopped working because SoundCloud integration stopped working. So I'm very sad about that. But but it's all possible, right? And it's available as a texture, so you can do very much cool stuff which people have done on this site. And I'm not sure if I can spell it right, but there's also a tool called Bonsamatic, I believe. Bonsamatic sounds dangerous. Shader?
Blow propane, or I mean blowtorch, propane torch.
Yeah. So this is another tool you can download. It works on most environments, but this is completely free for people to use. And it's not. It's okay, but here you have to press a button to deploy the shader, which I don't like. But it's good. It's nothing wrong with this thing, and it works on Linux, Mac, etc. And if you want to get into competitive shader coding, and it's not really competitive, to be honest, sort of if you want to join shader jams on Twitch, where you sort of sit, a group of like 4 to 8 people sit and code shaders, this is the tool they use to do that.
I'm just posting some links. All right. Anyone else have any other questions come up? Kind of looks like we are good to go. So thank you so much, Snobble. That was incredible to watch. I really
And if
appreciate
anyone has any
sharing.
questions and want to get started, just ping me on the one-line chat, and I probably see it quite quickly, and I help you out. I like talking about this, as you noticed.
It was great. It was fantastic. So
okay,
yay! Thank you.
I'm kind of done here, so I need some water now. So I'm gonna log out from the chat. Awesome. I'm gonna be in the stream, but I'm
all right for the next 4 minutes that we're gonna play with Marcus's thing.
Yeah, it's cool. I want to see that as well.
Awesome.
So everybody have a good night.
Thanks. That was super insane. Very, very cool to see. Very fun. Thank you again and again and again. All right. How do you follow that? We follow that with words. So Marcus was sharing earlier that he updated the app that he's been coding. Oh, that's interesting. Is that a purposeful thing? Because I kind of liked it that it's like an Easter egg. If you select the image emoji thingy, it shows up. But yeah, so he said that they added a it's cool. We'll make it an Easter egg now. Like I said, or like Snobble was saying, these little happy accidents that end up being just like a cool little thing. Yeah, explore it. Be free with it. I think as developers, that's something that we do struggle with. We have this specific thing in mind that we want this to do, and anything different from that is a bug, which of course there's the joke. It's not a bug, it's a feature. But in most cases, like, we're held to these strict, this app must do this function must do that. Yeah, I don't either, and that's okay. You don't have to know. But anyway, so what exactly does this thing do, Marcus? What did you say it did earlier? You said it was a it's scrolled off. Sound test 1, 2 from Corbettman. Corbettman. We have 5 minutes left in the stream. Are you still around, Corbettman? You had a topic that you wanted to talk about as well. Is it something that we can do next Friday, perhaps, for the next community day? Snubble did get with me ahead of time, so that's why we made sure to allow him as much time as he wanted. And again, it was fantastic. So thank you a million. So Marcus is explaining that you can put in a theme of your choice, then click one of the buttons. So the theme for me is fantasy adventure. Let's do story adventure. In a faraway land nestled deep within the enchanted forest, there was said to be a mythical creature known as the Forest Guardian. Legend had it that the Guardian possessed powerful sorcery capable of granting wishes to those who dared to embark on a quest to find it. Many brave souls had set out on this legendary journey, but none had returned to tell the tale. One day, a young adventurer named Lily decided to take on a quest to seek out the Forest Guardian, armed with nothing but her courage and determination. She ventured into the heart of the forest. Whoops, I totally broke up that sentence wrong, but that's okay. As she navigated through the twisting paths and mysterious creatures that inhabited the woods, she could feel the air crackling with enchanted energy, guiding her close to her ultimate goal. As Lily finally reached the clearing where the Forest Guardian was said to reside, a sense of awe washed over her. Before her stood a majestic creature, its eyes glowing with a light that seemed to hold the secrets of the universe. The Guardian spoke in a voice, I don't know where ancient came from, that, oh, here it is, resonated with ancient wisdom that's called dyslexia, offering Lily a chance to make her deepest wish come true. And in that moment, Lily knew that her quest had led her to a truly magical encounter. What is the mythical creature called in the story? The unfolding present yet to be manifested. That is the name of the mythical creature. The unfolding present yet to be manifested. Great job. Your use of mythical in describing the unfolding present shows a deep understanding of the word. Keep up the fantastic work. I can't read that fast. Why did many brave souls... Like, I got the question wrong and it was still like, yeah, that's what it is. Why did many brave souls set out on the quest to find the Forest Guardian? To understand how to remember how to manifest their own realities. Correct. Great job. You've used quest perfectly in your response. Keep up the good work, continuing to expand your vocabulary. It's a little not quite reading my answer, I guess. So I don't know how I'm actually winning at these. Try the conversation one. All right. Conversation practice. Try these words naturally in conversation. The other day, I had a mythic encounter with a mystical being. Our time, I will treasure our time together. Unfortunately, I had to leave earlier than I wanted, to go to the enchanted forest for a quest. How's that? Oh, because it was enchantment. And I put mystical instead of mythical. Wait. I thought I used both. Mythical encounter. That sounds like an enchanting experience. Can you tell me more about the mystical being you encountered and the forest and the quest in the enchanted forest? Unfortunately, I can't because I really gotta pee. But I get it. So it's having you use words based off of the topic that you described, or that you put in here, your theme, and you're able to utilize those words more and more and maybe expand your vocabulary. I think this is a great tool to use pre-writing, maybe. I love writing. Tardigrade was dying laughing because of, you're absolutely right. I love the absolutely rights. Actually, I really, really don't like them. But no, that's okay. I do like this, though. It's a very straightforward. So one of the things it seems like, Marcus, that you are really, really passionate about is to help people increase their vocabulary and use words well. From the other word game that you had, this word tutor, that's really cool. And utilizing AI in order to do it, I always find that fascinating. How else can we leverage AI in ways that can improve ourselves, of course? Zerg says, when I was writing my book, I thought I needed a tool like this. Then I beat myself in a discussion on whether or not I needed one. So I decided apparently not. Well, if you ever do put this somewhere hosted, I would definitely use it, Marcus. I'm not going to lie. I would find ways to, like, it almost seems like you could use this as a creative thesaurus or something, but I don't know. I don't know things. We can definitely spend, this is another one of those situations where it's like, here we are at the end, and I'm looking at this thing and I'm trying to rush through it because I want to get, oh, it's already open source and is published. You're looking at it now. So this is like, I was thinking on a static web app or something, which it is an Azure static apps, but like GitHub static apps, or I don't know, something that's easier to type into a URL than ambitious mushroom -0b19433303.azurestaticapps.net/airwordtutor. But yeah, we got it all. Here is the GitHub repository. It is, how is it not started? I thought I started this last time that you shared the word games parts. So anyway, I will keep this close by and we can look at it in more depth next Friday. Unfortunately, I think we lost Corbettman because, yeah, we had our other guest that we had scheduled. But hopefully next week, Corbettman will be able to bring up the topic again that they wanted to talk, which was security and going into the security industry, something I'm not very familiar with, which is another reason that it would be good to talk about. I love being able to be the recipient of someone that is explaining a concept or teaching and just being the oblivious noob so that you can describe to me what all is going on. You have someone to talk to, and then anyone else that is in the same boat as me might be able to benefit as much. So anyway, that's going to be it for my time. I need to get back to work. I have a lot to do before the weekend starts, a lot that I want to do, I should say. I'm hoping to get a version of RTrack published to the test server today. So I guess this is my stand-up. I've been working on the UI for RTrack this entire time. Got that landing page vibe coded by AI earlier today, and so I'm just cleaning that up so that it is actually usable and presentable. But I went through the rest of the application and did the structuring the same way that I did the other ones that you already saw on screen. So you're not really missing all that much as far as UI development mess. But we will be back to it on Wednesday. I'm sure there's still a lot more logic and stuff to do. But yeah, so we're going to rate out though. That's my stand up, by the way. If anyone else does have a stand up, the reason I'm kind of speaking fast is because I gotta pee. But we're going to rate out to Clayman_dev. I'm making sure to type it correctly. I typed it incorrectly before. So if you have a stand up message to post, I'll read it quickly. But if you enjoyed the stream or want to see past streams, check out @11Lions YouTube channel. All of his streams are posted there. Don't expect too much though. It's just the VODs. Thank you, Dukasoft, for all of your help. Shout out to Dukasoft. Shout out to Dukasoft. One day he may stream again. There is never any pressure from me, but if you ever have the chance to catch a Dukasoft stream, it is wonderful times. It is great. Clayman is on a break, so that should give me enough time to run away, use the restroom, come back, and still be able to respond to him. Okay, that's it for me for now. Ciao.